Welcome to Modular Learning. In this video, I'm going to demonstrate multiple-site VLSM subnetting with the summarization. We can see the subnetting requirements. There are 3 sites in this example. Branch 1 that has 2 networks attached. Branch 2, 3 networks attached. And the headquarter has 1 LAN. 2 serial links connect branch 1 and branch 2 to headquarters. That requires 2 IPs per link. Now we're going to use the given network 172.1.0.0/20 to do the VLSM subnetting, create variable size of subnetworks for those networks. We will be doing the subnetting on a per site basis. So do the subnetting for branch 1 first, because this is the largest site. Finish site 1, branch 1. We must summarize. And then we will know what IP address range has been used by branch 1. We will use the next available IP range for branch 2 subnetting. Finish branch 2, again, we will do summarization. Summarize the 3 networks, create a summary, so we know what IP range has been claimed by branch 2. Then lastly, we will do the headquarter subnetting, and at the end, create the smallest subnetworks for those 2 links. Let's go. Start from branch 1. N1 is the largest network. We will start from the largest network to the smallest in 1 site. So branch 1, we use the given network, start from N1. N1 needs 1,000 hosts. Based on the number of hosts, we need to determine the number of host bits we need to accommodate 1,000 hosts. So use the 2 to the power of the number of host bits. We know we need 10 host bits, because 2 to the power of 10 give us 1024 IPs. That is just more than enough to cover 1,000 hosts. That is the best fit. Now, once the host bits determined, we calculate the network prefix length. That is the length of the IP address 32 minus the host bits 10. Give us network prefix length is 22. So we got the subnet mask is /22 to accommodate 1,000 hosts. Write it into the subnet mask is 255.255.252.0. Now we can write down the N1's subnet address, which is 172.1. We write the 3rd octet into binary because the network boundary is inside the 3rd octet. So originally /20, the network boundary was here, highlighted in red. That's the original network portion. Now we only need 10 host bits to accommodate 1,000 hosts, so that we can borrow 2 more bits for subnetting. That 2 bits labeled in blue is borrowed for subnetting. So we created a new network boundary, which is here. There are 22 network bits, 10 host bits. The subnet mask indicates the network boundary is here. Now, we can figure out the IP range for this network M1 when the host bits takes the highest value, goes up to all ones for the 10 host bits. That gives us the last IP, which is the broadcast IP address for M1. That is the third octet convert into decimal. That is a 3. So 172.1.3.255/22. That is the broadcast address. Any other IP in between the network address and the broadcast address are usable, like 172.1.0.1, the first usable. 172.1.3.254, that is the last usable address for M1. We finished the first subnet. Move on to N2. N2 is pretty easy. Need only 200 hosts. So in order to accommodate 200 hosts, we use the next available IP address, which is 172.1.4.0, right after N1. Then we're going to determine how many host bits we need for the subnetting. So obviously 8 bits. That 2 to the power of 8 give us 256 IP. That is just more than enough to cover 200 hosts. That's the host bits we need. Then the network prefix length is 32 minus 8/24 is the subnet mask. Right into formal subnet mask 255.255.255.0. And the subnet address for N2 is 172.1.4, write the 4 into binary, because the network boundary is inside here, /22. Then we borrow 2 more bits, create a /24 subnetwork. Those are the host portion, 8 bits, the last octet. So broadcast address is when the host bits taking the highest value, 1111, that's 4.255. That is /24 network for N2. We finished the site 1, the branch 1. Now we need to summarize these 2 networks. To do the summary, we simply list the 2 networks together and compare, find out the matching network bits starting from leftmost. The first 2 octets are the same, no need to convert into binary. The third octet is different, so we need to convert the third octet into binary. 4 is here, 0. Then compare bit by bit from leftmost towards the right. The first 5 bits are matching. The 6th is different. That creates the network boundary. So the left side matching bits highlighted in red are the network ID for the summary. Then we simply copy the left side matching network bits to the result line, reset the rest of the bits to 0. That gives us the summary network address. Then the network prefix length simply count the number of matching network bits. That's 8 plus 8, 16, plus 5, 21 bits is the prefix length. That's the subnet mask. Write it into the formal subnet mask. That's 255.255.248.0. That is the summary for branch 1. Now we need to write down the IP range. It starts from all 0 in host portion, going up to all 1s. That's the last IP in this summary range. Give us the IP range used by branch 1, that is 172.1.0.0, all the way up to 172.1.7.255. That address range has been claimed by branch 1. That also gives us the next available IP range we can use. That is 172.1.8.0/21. We will be using that 8.0/21 for branch 2. Let's go. We finished branch 1, then repeat the procedure for branch 2. We start from the largest network in branch 2, which is M5. That needs 300 hosts. Okay, then in order to accommodate 300 hosts, we need 9 host bits, because the formula 2 to the power of 9 give us 512 IP. That is the subnet just big enough to accommodate 300. If it's 8 bits, that's going to be smaller, not enough, only 256 IP, right? So that's how we determine the host bits must be 9. Then we can calculate the network prefix length. Use the length of IP address 32 minus the host bits 9. We got the subnet mask /23. Write it into formal subnet mask 255.255.254.0. That is the subnet mask for M5. Then we can write down the subnet address. That is the 172.1.8. Write 8 into binary because the network boundary is inside the third octet. /23 is right here. So you can see we need 9 host bits to accommodate 300 hosts. Originally, network prefix was 21, so we borrowed 2 more bits to create the subnetworks for /23. Then we use the first subnet. The subnet ID is the borrowed bits taking the value 00. And the range is when all the 9 bits takes the highest value all 1s. The host portion starting from all 0 going up to all 1s. That's the whole range for M5. Then we can see it's going up to 172.1.9.255. That is the broadcast address. The usable IP is 8.1 all the way up to 9.254. That is the subnet created for M5/23. Now move on to the second largest, M4, that requires 200 hosts. Then this is simple. 200 hosts, we need 8 bits. Next available is 10.0/23. So we use the next available network. Subnet this, create the subnetwork for M4. Based on the 200 hosts required, we need 8 bits. And the network prefix is 32 minus 8/24. That's the subnet mask 255.255.255.0. Now, M4's subnet address is 172.1.10. Write 10 into binary. Then we can see the original network prefix length is highlighted in red. We borrowed 1 bit. for subnetting created this /24. Then only 8 bits is the host portion. That gives us the range for M4. The host bits starting from all 0, going up to all 1, that's 255. So 10.0 up to 10.255, that's the IP range for M2. Simple. Let's continue. M3. M3 needs 100 hosts. Next available would be 172.1.11.0/24. Then to accommodate 100 hosts, we need only 7 bits. So we can borrow 1 more bit from this given network, create 2 subnetworks, then use the first one for N3. So subnet mask would be 32 minus 7, that's /25. In formal subnet mask, 255.255.255.128. Here is the subnet address for N3. That is 172.1.11.0/25. So the range is when the 7 host bits takes all ones. That is the 127. Now we finished branch 2. We need to summarize. To summarize the branch 2, there are 3 networks. We only need to compare the lowest network address with the highest address. So here is the lowest address is 172.1.8.0. The highest address is 172.1.11.0. So first the 2 octets are the same, matching. In order to figure out the matching bits in the 3rd octet, we need to write the 3rd octet into binary. So 8, 11. Then we compare bit by bit from leftmost towards the right. The first 6 bits are matching. The 7th bit is different. That creates the network boundary. The left side highlighted in red is the summary network ID. Then we copy the matching bits down to the results, reset the rest of the bits on the right. That is the summary network address. The prefix length is the number of matching network bits. That is 22 bits matching. And in the subnet mask, 255.255.252.0. That gives us the branch 2's summary, 172.1.8.0/22. That actually claimed the range from 172.1.8.0 all the way up to 172.1.11.255. The range is created when the host bits taking the highest value going up to all ones. That gives us the 3rd octet here. That is 11. And the last octet, 255. So that also gives us the picture. Next available network range is 172.1.12.0/22 available. Right now, all the way up to 11.255 are used by branch 1 and branch 2. Now, let's take the next available 12.0/22. Then we subnet it for headquarter. Headquarter N6 needs 400 hosts. Then again, we need 9 host bits to accommodate 400 hosts. 2 to the power of 9 gives us 512 IPs. That's big enough to cover 400. Same procedure. network prefix length is 32 minus 9. That gives us the subnet mask /23. That is the subnet mask for N6 255.255.254.0. Now, write down the subnet address for N6. That is 172.1.12.0/23. Then we can easily figure out the range based on the binary. When the host bits take the highest value all ones, that gives us the decimal value. The third octet is 13. The last octet is 255. So that is the range for N6. Now, we finished this HQ's LAN. The next available address is obviously 172.1.14.0/23. That is available for the links. So we use the next available network, 172.1.14.0/23, create the smallest subnetworks for the point-to-point links, connect branch 1 and branch 2 to headquarters. Now, only 2 IP, so obviously only 2 host bits. Then we use the given network. We can easily create the subnet mask /30, and the network right into binary. It's easy to see the bits borrowed. Originally /23, that's the given network prefix. Then we need only 2 host bits. We can borrow so many bits, 7 bits borrowed, and so create the smallest /30. Then that's very easy. Just 14.0 all the way to 14.3. That's the broadcast address for this smallest subnet. Then 14.1, 14.2 are usable, 2 usable IP. Then keep going. The next small network would be 14.4. And the broadcast address is 14.7. Usable IP 14.5, 14.6. Those are the smallest subnet created for the links. Now we finished. This is the result in the diagram. Branch 1 has 2 subnetworks, 172.1.0.0/22 and 172.1.4.0/24. Then the summary for these 2 networks is 172.1.0.0/21. That will be sent from branch 1 to HQ. The same branch 2 got 3 subnetworks created, variable length. The summary has been calculated. That's going to be 172.1.8.0/22. That's the multiple site variable subnetting with the summarization. Thanks for watching. If you found this video useful, please subscribe.